We have 9 classes again, and then after pixel intensity heat map, which is for the recognition of different types of data items, and then after we have these confusion matrices, and again the performance matrices of the algorithm for the digits data set. What is the outcome of decision tree? It is 85.27. Light GBM is giving 98.05. Random forest is giving 97.22. And again, the stacking classifier is giving you 98.33. So, what is the conclusion finally? After completing the experiment of all these 4 data sets with 4 machine learning algorithms, that we have best performance in ensemble machine learning algorithms, and among all these ensemble machine learning algorithms where we have 3 verticals, 3 components, boosting, bagging, boosting and stacking is much more better. Alright, so this is concluded here. But the thing is that what happened with the data set which is not performing well? No algorithm is performing well. Which was the data set? What was the name of that data set for which it is not performing? Breast cancer, MNIST, digits, or Titanic? For which? For which data set? Okay, coming to the conclusion. This is the ROC curves for the validation, and then after I am coming to the findings of this study. That stacking classifier, what are the findings of this study? That is stacking classifier, in case of breast cancer, it is giving 97.36% accuracy, and for Titanic, it is 84.92. And then after for MNIST, it is 98.89, and for digits, it is 98.33. So which one is very much less? Titanic. For Titanic data set, all these 4 algorithms are not working. What is the reason behind this? What should be remedy to improve the algorithms for this particular type of data set? That is really very important. So it is concluded that 2 things are concluded very properly by this experiment and study, that ensemble machine learning algorithms are much more better compared to standalone machine learning algorithms. Means always decision tree will be better compared to random forest. In ensemble machine learning algorithms, we have 3 categories: bagging, boosting and stacking. Stacking will always be performing well compared to other algorithms. But it is not universally truth. It is not applicable on all cases. There are some data sets which have their own nature. Some of them may have problem of underfitting. Some of them may have problem of overfitting. Some of them may have problem of generalization. Lot of problems are there. For example, there is a data set that has 500 instances into it, but 450 are related to yes, and only 50 are related to no. So do you feel that this is a good data set, or all the machine learning algorithms will give good result for this particular data set? No, because this is an imbalanced data set. For any imbalanced data set, we have to go for other provisions. We have to handle it before going to process it. I will discuss it later with the new proposal, that if you have such kind of imbalanced data set where you have 450 data for the yes and 50 for no among all 500 instances, so what will you do? You have to go for a cross validation technique in which you have to take care that for each of the each of the section of the particular data set, whatever you created, that must contain at least 45. For example, I am dividing it into 10 sections, into 10 subparts. So each section will have 50 data sets. In these 50 data sets, we should have 45 with yes and 5 with no. And if we are not taking care of this particular constraint, what will happen? There will be 3 to 4 segments where you only have yes data set. That is really a problem for a cross-validation technique. So such type of problems will be addressed with the cross-validation that I will discuss later. So here we concluded that this is happening. Ensemble learning algorithms are much more better, and stacking algorithms are much more better compared to bagging and boosting. But now there is one problem which is not addressed till now, and that problem is what happened with Titanic. Means Titanic data set is not performing with all these algorithms. So we created one proposal for it. We introduced several new segments into a machine learning algorithm that I will discuss in a very abstract form, because this paper is submitted to some journal. So I will not go very much deep into in the details of the implementation or technical details. So I will just propose here an abstract format of that particular proposal. So you just see here. This proposal is going to address the problem of Titanic dataset, because into that we are having highest accuracy of approx 89%. So this is the proposal. I'm just explaining all these steps that we have here. This particular proposal have following features: data pre-processing and feature engineering. And into that we have 3 special segments. Number 1, feature construction. Do you know what is feature construction? I am putting here one example to understand what is feature construction. Feature construction means, for example, we have attendance, we have mid-sem marks, and then after we have some other performance index related to students. There are 3 performance index we have into the data set. Now I am creating here a new index, that is PI, performance indicator. And what is that? 0.3 into attendance, 0.3 into mid-semester marks. These weights may be assigned by the user or the administrator who is using this kind of system. So what am I doing? We have 3 fundamental attributes of the data set, but we are creating here a new particular attribute or instance into the data set. So that is basically known as feature construction. After that we have isolation forest, outliers. Outlier means in all kind of data sets we have outliers, but they are very limited. So we have to take care that these are the isolation forest. How can we isolate them? Because they are very less in number, so it is very easy to isolate them. So that's why this proposal has the facility of isolation forest. Then after we have scaling and normalization technique, and I think it is very well known to you that what are the scaling and normalization technique in machine learning algorithms. So I will come to base models which are used into this particular ensemble approach. So into this we have random forest, gradient boosting, support vector machine, and XGBoost. And we tried to have all kind of machine learning algorithms to be included into this particular stacking proposal, where we have these random forest, gradient boosting, support vector machine, and XGBoost. These are the several machine learning algorithms which are combined into this proposal. Now, when we are going to supply this data set to this particular integrated environment of machine learning models, we have this stratified k-fold training data set. What is stratified k-fold training? Stratified k-fold training means we have a data set. Again, I am putting here one example, that if you have 1000 instances into a data set and 900 instances are related to yes and 100 instances are related to no, then after when you perform the cross validation onto this data set, you have to take care that in each of the section or subsection of this data set, whatever you are going to create, that must contain 90 yes and 10 no. So that is basically known as stratified cross validation, which is not taken care whenever we are going to implement this cross validation only, which without stratification. So stratified k-fold training is being used here for the imbalanced data set. Yes.
So can we take equal number of yes or yes and no in each segment?
Yes, your suggestion is good, but what is happening whenever you are taking, what is the way to create a data set? The creation of data set is not in your hand actually. So what happens whenever you are going to create a data set, that will be given by the third party. All right, third party means the doctors, or for example, I want to create a data set related to students. So who are the supplier of this information? The students. They will supply. So it is a coincidence. Sometimes it happens that you are not getting the data whatever you wish. That means the 50% yes and 50% no.
So we can repeat the no values in different segments.
No, that may be covered into the data processing part. But what is happening here? I'm telling you that if the data is imbalanced, there is no problem. If the data is imbalanced, there is no problem. If you have 900 instances for yes and 100 instances for no, there is no problem at all. But you have to follow this stratified cross validation, because this is not in your hand. Otherwise, this will be a data set which is manipulated. If you are doing anything, that will be a manipulated data. So whatever the original data you have and that is imbalanced, what is the strategy to handle it? So that strategy is stratified k-fold cross validation. So that will be supplied to different machine learning algorithms. All right. And then after, actually the mechanism of doing decision making, that is totally based on the probability. Probability means if there are 4 classifiers and the decision making, what is the probability for yes? If there are 4 classifiers, what is the probability of making it yes or no? Just tell me. 0.25. That is the probability. So accordingly, it may be possible that all the classifiers are 4, means all the 4 classifiers are concluding it is yes. It may be possible that all the 4 classifiers are saying that it is no. And there is another possibility to have 3 yes, 1 no, 2 yes, 2 no. These are the different possibilities. And every time you will have different probabilities. Based on these probabilities, you will conclude the final outcome based on the majority voting or any kind of other aggregation mechanisms that you have among all the basic or fundamental algorithms that we have. For example, here we have random forest, gradient boosting, and support vector machine. So we have to apply some aggregation mechanism among all these 4 machine learning algorithms. All right. So those aggregation mechanism was based on probabilities, but now it is converted into a rank. Rank means if the probability is 0.25, it is converted into 0, and if it is 0.75, it is converted into 1. So accordingly, the classification of these probabilities is done into ranks. All right. So whenever you have rank which are independent from the probability concept, that is implemented for the decision making process, means the algorithm is implemented for this particular ranking system. After that, what is happening? We have semi-supervised learning with the pseudo-labeling. Means whatever the rank-based decision is done, that will be having some kind of labeling mechanism. Labeling mechanism means you can see here that this semi-supervised or pseudo labeling, if pseudo labels are having value 1 and 0, there are only two possibility for the pseudo labeling, 1 or 0, but it will be depending on the rank. If you have rank greater than 0.5, it will be 1, and if it is less, then it is 0. So accordingly, pseudo labeling will be done, and this pseudo labeling will be implemented for the decision making process or aggregation mechanism for all other machine learning techniques that you have. So finally, this is the final model learning will be based on this particular pseudo labeling and rank aggregation mechanism, and then after the results will be concluded, and this particular model is implemented into Python